Right, folks, this is doing the math quiz. So basically we know that this is our function, and then the question will obviously want you to find like every other thing. Okay, honestly I don't know how to find each term, like each part on its own, but I know like the important steps that you need to go through, and I'll try to explain. Alright, so if I recall correctly, the question wants you to find stationary point, and then they want you to find whether it's max or min for the stationary point, and then they want you to find concave up or down or something like that, and then they want you to find inflection. Is it inflection or inflection? I think it's inflection. Okay, basically we'll be trying to find this for. Okay, wait, let me take a look at my my student card. Let me see. Minimum and then inflection. You know what? I can't be bothered. Alright. So first thing first, we need to find stationary point. So how do you find stationary point? Very simple. Stationary point is basically when the gradient, dude, I actually don't know how to spell, when the gradient of graph equals to 0, or damn it, how do I mute this? Mute for 8 hours. There we go. Where your change in x and your change in y equals to 0, means no change at all, aka you're just flatlining. Your graph have reached a flat line, you know, like something like this. Yep. So gradient is basically what? Change of y over change of x. Change of y over change of x. Or in this case, because the question put it as function x, it's just f prime x. Okay? I can also do this, you know, doesn't matter. And then let's do the differentiation. And in this case, product rule. Okay, so product rule, we'll just do the first one first. So exponential. Okay, let's do it step by step, shall we? Okay, so to differentiate exponential to the power of 2 square, you basically is equals to the dx of 2x times, then you just copy the exponential. That's why I love exponential a lot. They don't really change much. So this gives you 2x. Alright. And then for the other one, the dx of x minus 1, you basically bring down the 2, copy over. Okay, this is how I like to do it, okay? You bring down the power, you copy whatever inside, power minus 1, and then times the differentiation of whatever inside. Basically chain rule, okay? So in this case, you get 2x minus 1. Alright? And then now you put these two together. Because my handwriting is ugly, I'm just gonna yoink in, and then yep. So f prime x equals to 2e2x, and then I copy, plus then I copy this one, and then 2x minus 1. I can leave it like that, no problem, but to make life easier, let's simplify this, okay? I think we can simplify this a lot. The common factor we have here, or the common term we have here is this 2, and then this as well. So technically the only difference is really just this square over here. Let's just use a different blue. Over this essentially becomes a 1, and then this essentially just have a x minus 1. So if I'm not wrong, it is x minus 1 plus 1. Okay, so you get a 2x ln and then x minus 1. So this is your gradient, your slope, your m, your change of y over change of x, dy dx, whatever you like to call it, okay? So now with this, let's just, okay, let's remove this whole thing, and then this one, you come up here. So now that I have my gradient, remember what I said about stationary point? It's basically when my gradient becomes 0. So for stationary point, okay, maybe to make it easier to understand, when my m, or should I just say when this equals to 0. Notice, I know a lot of people may get confused, but there is a difference between this and there's a difference between this. Okay, this just means that my x value equals to 0. This just means that my y value equals to 0. Alright, so that's the difference. I hope I mean, a lot of y'all may know it, but I just want to point it out just in case. Okay, back to the thing. 2x x squared x minus 1 equals to 0. Honestly, constant 2 get cancelled out. Ln x2 also get cancelled out, because you can take it as a constant value. Okay, that's the power of ln. I mean exponential, sorry, that's the power of exponential. So essentially, you're just left with x and x minus 1 equals to 0. Then you're left with x equals to 0 or x equals to 1. Take note, this is not the answer, okay? This is just your x coordinates for the respective stationary points. What you want is you also want the y value. In this case, you want the fx value. Now this is where you do fx equals to 0 equals to what? And then f1 equals to what? Alright. Oh shit, the mic might be hitting my shirt, so you might be hearing a lot of peeking. Oh no. Okay. Give me a moment. I'm gonna take out my calculator, so you guys may hear a bit of a wind from my fan or whatever disturbance. I got a feeling that the mic may not be the best. Okay. The mic is moving too much. Stop moving. Okay. Can. Good. So I have ln 20 times 0 minus 1 square. So I'm just going to use a different color. So when my x equals to 0, f0 equals to 1, and then when my x equals to 1, my f1 equals to, let me just compute, 1 minus 1 is 0, so you essentially get 0. So your answer is basically this and this are my stationary point. You get it, okay. So this is your stationary point. Okay, just to make life easier for me, I'm just gonna put it right here that my stationary point are as such. Moving on, maximum or minimum. Alright. So in this case, a lot of you may be confused with the instructions, because you guys see the lecture notes that if there is only one stationary point, okay, in this case, then usually like, oh yeah, sorry, what the hell, bro? Okay, if there's only one stationary point, then you guys may do like, for example, if the stationary point equals to x, then you will do x less than 0, x more than 0. Why? Because 0 is your stationary point. So essentially, whatever in your 0 is just like, yeah, there is no up or down. So if you put 0, it's gonna haywire your working a little bit. So you have to put something that is less than a stationary point, more than a stationary point. So this is what happens if there is only one stationary point. So if your stationary point equals to 0, you have to find for x less than 0 or x more than 0. But then in this case, you have two stationary points. So how do I do it instead? So two stationary points, remember, for my stationary point, x equals to 1 and x equals to 0. So same thing, x less than 0, x more than 0, and for my second one, x less than 1, x more than 1. But how can I make life a lot easier? Because technically, if you think about it, these two values fall, you can say that it falls under this value over here. Am I right? I mean, this one can be, you know, more than 1, but whatever. So instead of writing it like this, like 4 equations separately, why not I combine the two middle ones together? So it becomes x more than 0, but at the same time my x is less than 0. Alright, and then same thing, copy the last one, which is x greater than 1. Alright, so just to help you guys visualize it back again, it's basically what am I doing? So it's x more than 0, x less than 1. So I am just combining these two equations together. Okay? And then now what do I put on my left side? Remember that my equation is, if I'm not wrong, is 2x e 2x over x minus 1. I believe, wait, let me check. Yes, it is. Okay. So nothing wrong with putting the whole ass equation inside here. Nothing wrong, honestly. But just like your CS 1010, you would want to, you know, split it out so it's much cleaner, much nicer for you. So you can put a 2x or you can put x, up to you. Some people feel safer if they include all the variables, up to you. Some people know that 2 is a constant, so they do not need to put it in at all. Doesn't matter, I don't care. So you have a 2x, you have a exponential 2x, and then you have a x minus 1. And at the very end, you need to see whether your fx is up or down. Sorry, f prime x is up or down. Your gradient, basically. So let's try to do it one by one, okay? Okay, let's start with exponential first. I think that's quite straightforward. Exponential, if you notice, it will always be a positive for whatever value of x. Don't believe me? Just punch in your calculator. I'm too lazy to punch, so just believe me. Alright, next, 2x. If 2x is less than 0, so let's take negative 1 for example. Negative 1 times 2, negative 2, that's a negative. Maybe for negative, I'll do red color, so it's much easier to see. Then x more than, as long as x is more than 0, and you know over here is a positive overall, and the plus, and then you know that this is also a plus. X minus 1. Anything less than 0 minus 1 will always be a negative. So just boom, negative. How about x in between 0 and 1 minus 1? Well, even if x equals to 0.99, 0.99 minus 1 is what? Negative 0.01. So in this case, it's still a negative. Okay, let me just go ahead and check my answer. Yep. And then last but not least, 1 minus 1 is equals to 0, or 1.1 minus 1 equals to 0. A good gauge is just to always add or minus a 0.1. So for example, you can use numbers, for this number you can use like minus 0.1, and then this number you can use maybe, I don't know, 0.1 or 0.9, up to you. And then this one you can just use 1.1. Okay? So now let's compute. Because you must understand that I'm still taking all these values and adding them together, okay, to give you this. So if this is a negative value, okay, let's take a look at the first row, column. If this is a negative value, this is a positive value, and this is a negative value, it will give me an overall positive value. So this is positive, which means it is going up. This have one negative, so anything times negative will give you a negative. So this is going down. This is overall positive, pretty straightforward. So there you have it. You have your graphs before and after each stationary point. Okay? But I can't really prove whether this is maximum or minimum. Can I? Technically I can, but the answer will want you to more or less try to guarantee it, because sometimes, you may go wrong, and then who knows, this may be a going up instead. I don't know. Okay? So how do you prove it? Very simple. This is where second order derivative comes in. What is second order derivative? Let's recap, okay? First order derivative is your rate of change of your graph. So essentially, it basically, what is the gradient of that graph at that certain particular specific point. Second order derivative, however, is basically how is your graph changing as we with respective to x. So is your graph like let's say for example this is my graph, right? Okay, or this is whatever. So is my graph like concaving down, or is my graph concaving up? So second order derivative is just to see how your gradient change with the graph. Okay? Or with like x if I'm confident enough to say that. So in this case, we will need to do second order derivative. Alright? So let's just do that, I guess. Can I think this should be enough space. So we know that our f prime equals to 2x ln blah blah blah. Okay. So what is our f prime prime? AKA second order derivative. So the 2y dx square, I believe. Yeah, whatever. So this is also product rule, but this product rule is a lot more complicated. Why? Because you have now 3 product. But not to worry, let's just go through the motion. Yeah, you complain all you want, but you still have to do it, right? Might as well. Alright, let's go ahead and differentiate the first one first. So it's basically 2, then just copy the rest, plus then you copy this one, 2x, and differentiate the second one, which is 2ex, copy the last one, and then copy both the front, and then differentiate the last one, which is just 1. Nice. Alright, let's slowly bring out the common stuff. So the common stuff is 2 ln e, I believe. 2 exponential 2x. Why am I saying ln? I'm so sorry. Alright, so now that's the common stuff, I guess. So let's look at the first one. Now we brought out the common stuff, so we have x minus 1 plus, then the second one we brought out the common stuff, so we now have 2x over x minus 1 plus, then the last one we brought out the common stuff, x. That gives me 2 ln x, 2 exponential. Why am I saying ln? I'm so sorry, guys. So it's basically am I tripping? I think I'm right. Okay. It's basically, so x minus 1 plus 2x squared minus 2x plus x. So let's cancel each other out. X plus x minus 2x is just 0, and then minus 1. So now you have 2x over 2x squared minus 1. Am I correct? I'm doubting myself, bro. I am correct. Oh my god. Okay, let's just leave it like this, okay? I just want to leave it like this. Alright. So this is my second order derivative. And now how do I how do I compress all this? Whatever. Yoink. You know, I'm just gonna I can't be bothered, bro. Okay, so let's recall. We have my fx equals to this little boy over here. My f prime x equals to 2x ln ex minus 1. Then my f prime prime equals to dang it, I forgot. To ln 2x squared over 2x squared minus 1. Yep. Alright, so second order derivative. In order to find our stage, in order to find whether it's maximum minimum, we understand that our this one equals to 0, which gives us x equals to 1 or x equals to 0. Then let's say, for example, this is our f prime. Okay, I'm just going to do f prime. So when f prime, the gradient, when the second order equals to 0, you get the maximum or minimum point. Why is that? Because just take note that every time you differentiate, right, you're basically finding the rate of change of the thing that you're differentiating. So because second order is basically differentiating first order, I am finding the rate of change of first order. And in order for my first order to be a maximum or minimum, the rate of change have to be 0, which means my second order derivative have it to equal 0. I closed my eyes saying that, by the way, because that was essentially me rapping. So when my this bad boy equals to 0, no, I am retarded. We already know that it is equals to, we already know that the rate of change is already equal to 0. So in this case, we want to find whether it's max or min. So we have to substitute this value and this value. I am so stupid. Ignore whatever I just said the last 39 seconds. Okay? So let's sub this into our thing. Alright? So we have 2 ln 2 0 times 2 times 2 over 0 square minus 1. Yoo-hoo-hoo, you get a -2. Do you actually? Oh my god, you do. And at this point, when at this particular coordinates, because we already found a y value earlier, remember, this is less than 0, so this is a maximum. And then if you recall, remember this very first point, it was like a up, down, up. So yeah, it makes sense that this is a maximum, and then our next one should be a minimum. But let's confirm it, shall we? F prime 1 equals to, key in your calculator. Bam, 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 bam. Wow, you get a very weird number. You get 14.78, which is for our this coordinate, and it is more than 0, so it is a minimum. And there you have it. You found whether it's a max or min. Alright, next they will want you to find whether it concave up or concave down. What does that mean? Basically, why my right, because I can scroll up. Basically what it means is my graph concaving up like this, or if my graph concaving down like this. Another way to see it, this guy is going for the moon, he's skyrocketing, and this is how, you know, rocket always like to fly, you know, boom, he's skyrocketing. So this guy is going to concave up. On the other hand, this guy is like, whoa, I'm peaking, oh no, I'm gonna drop. Oh no, he's gonna drop. He's gonna go down. Yeah, so this is how you can tell yourself, like, how to remember the shape for concave up and a shape for concave down. Okay, what do we want to find again? We want to find the inflection point when it influx. So what does that mean? When does it influx? So now remember the thing that I told you to forget? Now remember it here. Okay, influx is basically the point where they change from a concave up to a concave down, or when they change from a concave down to a concave up. I don't care. It's basically when the concave change, the concavity or whatever they call it. Okay, oops. Whoops. Okay, so inflection point happens, okay, when, remember that this graph is fx, so inflection point happens when the gradient of this equals to 0. So if I recall correctly, it is, am I right? Oh boy, yes, when this equals to 0, and then because we know that this will be a constant, this is also a constant, so we're just left with 2x squared minus 1 equal to 0. Actually, do we need to include this? You know what, I'm not going to include this. I don't know whether I'm right or wrong for this one to include or to exclude, but other than that, the concept is there, so yay. So this is basically plus minus 1 over half. So when x is either of these two coordinates, is basically when my concavity change. And then same thing. God, I'm actually so tired of doing this. But for you, I'll do it. Who am I speaking to? I don't know. So basically when x less than negative this, same thing, same principle. Because I have two, I can okay, I'm just going to draw this higher. I can do x more than negative. Yeah, I can do x less than this, and then x more than this. Remember what I said? I can combine these two, so it's x more than this, and then x less than this. Right? Same thing. Do I have my... Oh, I do. Okay. I have my this. So I'm just going to split it out. You don't need to care about the two. So essentially, you only got two equations left. Alright. Same thing. Do the same. This is a plus. This is a plus. This is a plus. And then... Yep. And then this is probably... I can't be bothered. I'm so sorry, guys. Plus, minus, plus. Plus, minus, plus. Then when I solve it, this is plus, minus, plus. So this is basically concave up, concave down, concave up. So at this point are my inflection. Or basically this graph will look something like this. So I have 2 points, like one here, something like that. I forgot what the question I want you to find, whatever. But ultimately I just want to find the points where it's concave. So you just need to sub in the value. And then you get your answer. I'm gonna be honest, I'm tired, okay? It's 8:17 p.m. And then you guys should get your answer. Okay, so just sub it into this value of this. And then you should get your inflection point, whatever. You should get something, okay? Yeah, thanks for dealing with my nonsense. I like to do cursive. I learned cursive in 1 year.